You are welcome again. So we are going to start now with the first Fourier coefficient, which is A naught. So we are going to continue using equation 6.1 that we have in our lecture notes, which we have all seen clearly. We know about this, that that is the simple expression for the Fourier series where f of x is periodic, and it's divine within the interval minus pi to pi. So looking at the 6.1 now, like I've said earlier, we need to find A naught, A head, and Bn. I know in the last video I explained the reason why we don't need to find B naught. We don't need B naught because if at all there will be a B naught, that will be B naught sine 0x, and sine 0 is what is 0. So 0 times B naught will give us 0. So we don't even need to worry ourselves to find B naught. So let's go to the first step. We need to integrate both sides from minus pi to pi. But remember that this series here is a representation of a1 cos 1x, a2 cos 2x, a3 cos 3x, up to up to an cos nx. And at the same time, b1 sine 1x, b2 sine 2x, up to like that. So instead of us to be picking them one after the other, we can actually pick the series to have this on the screen. So if we integrate, we can see clearly now that 7.1 we hold. Here we are integrating, we're having definite integral from minus pi to pi. So we have this expression. As you can see, it's very simple. We integrate a naught from minus pi to pi dx. We integrate an cos nx minus pi to pi. We integrate bn sin nx from minus pi to pi. So we have equals 7.1. Now let's look at it now. If you pick the first term of 7.1, what is the first term? That is the integral minus pi to pi a naught dx. So if you integrate a naught, there is x power 0 here. So if you integrate that, you have a naught x. Remember that we're integrating. So we have it from minus pi to pi. So we need to evaluate the definite integral. That will give us a naught pi minus pi. Do you know the reason is because we need to evaluate x from pi minus pi, and that will give us a naught to pi. So that is how we obtain that. Let's proceed again. We need to continue to the second term of equation 7.1, which means that we need to evaluate the integral from minus pi to pi an cos nx dx. Okay, so if we integrate cos nx, what we are going to have is sin nx over n. Don't forget integration. If you integrate cos nx, you have sin nx, then you integrate nx again to give you, and then you divide it by 8. So that will give us n sin nx over n. Then we evaluate from minus pi to pi. So this will give us an over n, n will come outside. Then you have sin nx of n pi, then minus sin minus n pi. So don't forget that sin x is an odd function. So if sin x is an odd function, that means that sin minus n pi is the same thing as minus sin n pi. So if you substitute that one into our former expression we have this on the screen. So don't forget that we only use the fact that sin minus n pi is equals to minus sin n pi. So if you do that, we can now see that integral from minus pi to pi an cos nx dx, it will give us 2 of sin nx multiplied by an over n. That is what we can see on the screen. That is 2an over n sin n pi. So let's proceed to the third term of equation 7.1. Here we need to evaluate bn sin nx dx. So if we integrate sin nx, what we are going to have is minus cos nx over n. So we evaluate from minus pi to pi. So that will give us minus bn over n. Please take note of this one here is bn, not an. Please excuse me for that. This is bn. So we have it to be minus bn over n, then cos n pi minus cos n pi. So that is the evaluation. You evaluate there. So the next thing now is the fact that cos minus n pi is equals to cos n pi. Because cos x is an even function. So if it's an even function, cos minus nx will give us cos n pi. Cos minus n pi will give us cos n pi. So if we substitute this one into the expression, we have minus bn over n, then cos n pi minus cos n pi. And cos n pi minus cos n pi will give us what? Will give us 0. So that one is for that. So let's proceed. That means that integral minus pi to pi bn sin nx ds is 0. So if we substitute all this expression back to this, we've obtained the first term, second, third. So if we substitute everything back, this is what we obtain. You have minus pi over pi fx dx, then is equals to 2 pi a naught plus 2 a n over n sin n pi plus 0. Okay? So there's one thing again, that is the periodicity property of sin n pi. At all the integer of n, sin n pi will always give us 0. So if that is the case, that means that this term, which is the second here, which is 2 over an divided by n, sin n pi will always be 0. So if you do that, then we obtain this expression here. So we can now say that a naught is indeed 1 over 2 pi integral minus pi to pi f of x dx. Thank you for watching. So you can proceed to the lecture notes now, where you're going to do the assignment 7.1. Thank you.